What is the geometric meaning of linear system solutions? Imagine trying to find where two or more shapes in space meet. That's what solving a system of linear equations is all about. It's like finding the common point where lines, planes, or higher dimensional objects cross. When you have two variables, each equation makes a line in a flat plane. The solution is where those lines intersect. If they cross at one point, that's a unique solution. If they run alongside each other and never meet, there's no solution. But if they are the same line, then every point on that line works, giving you infinitely many solutions. Now, when you add a third variable, each equation becomes a flat surface, called a plane in three-dimensional space. The solutions are where these planes meet. Sometimes they just touch at one point, which is a single solution. Other times they share a line, meaning there are infinitely many solutions along that line. Sometimes the planes are parallel and don't meet at all, so no solutions exist. When you work with more variables, each equation corresponds to a hyperplane in higher dimensional space. The solutions are where all these hyperplanes intersect. This intersection can be a single point, a line, a flat plane, or even a more complex shape called an affine subspace. Think of solving a system as finding the common space shared by all these geometric objects. If only one point is shared, you have a unique solution. If many points from a line or a plane, you have infinitely many solutions. If no point works for all equations, then there is no solution. Visualizing solutions this way helps you see what the numbers and symbols really mean. It connects algebra to space and shapes, making the idea easier to understand. For example, in real life, finding where two roads cross is like solving a system of equations. In engineering, the intersection of different surfaces can show where constraints meet. In data science or computer graphics, understanding these intersections helps create models and images. So, thinking of solutions as intersections of lines, planes, or hyperplanes makes solving equations more visual and less abstract. It's like turning algebra into a puzzle of shapes and spaces, which can be much easier to grasp.